Section 2.4, number 6, they're just kind of giving you this little supposal here of what this thing could look like. I went ahead and wrote it as a piecewise defined function. I don't know why they didn't. It's f of x. It's equaling two different things for two different domains, so there you go. So I thought we would go ahead and graph this thing. Notice it's a constant function on both sides here. It just has a y value of 2 for all values of x less than 3. So if I were to just assume 1 and 2, okay, for everything less than 3, open dot right there, we would have a horizontal ray going off here to the left. And then, when x is greater than 3, we would jump all the way down to -4, have an open dot there, and this thing would be shooting off to the right like that. So that's what this function f of x looks like, and they want us to know, I kind of wrote the question a little different way than they did, but what is f of 3 if f is left continuous at x equals 3? Okay, guys, in order for this function to be left continuous, one of those two empty dots is going to have to be filled in. And for it to be left continuous, we need the limit as x approaches 3 from the left to equal the value of f of 3. Well, as we approach 3 from the left, we're here, guys, with a y value of 2, and we just keep moving closer and closer and closer and closer. We would actually fill in that particular dot right there. So in order for this thing to be left continuous at 3, f of 3 would have to equal 2. And then, if we wanted it to be right continuous at 3, we would just have the exact opposite thing going on. The value of f of 3 would need to equal our limit as x approaches 3 from the right, which is going to be -4. So -4 would have to go there for this function to be right continuous at 3. And that's all they were looking for here for number 6.